This is Mridula K from Final Year BDS. And today, my topic is on bioactive materials. That is, go through the contents. It is going to be introduction and what is bioactivity, evolution of bioactive materials, their ideal characteristics, classification of bioactive materials, and the types of bioactive materials that are used. Now, their properties, their composition, and their advantages and drawbacks, then the conclusion. To move on to the introduction. So, what are bioactive materials? Materials that elicit a biological response leading to the formation of hydroxyapatite or direct bonding with the heart tissues. They stimulate healing, repair, and regeneration in vital tissues. In endodontics, these bioactive materials are used in pulp capping, epexification, during perforation repair, and as a root end filling material. What is bioactivity as such? Bioactivity is defined by different authors, and there are a lot of definitions. It is the ability of a material to elicit a response in living tissue. The other definition goes bioactive material must be able to elicit a biological response at the interface and induce a formation of bond between the tissue and the material. Now to the evolution of bioactive materials. First material was introduced by Dr. Herman in the year 1920, which was calcium hydroxide. It had a remineralizing ability. Mineralization was possible. And then next came the mineral trioxide aggregate, which was introduced by Torabin Najad in 1990. It is also called as the Portland cement, which was a landmark and increased the attention towards silicate-based cement. Now, the advanced cement like calcium silicate cement, bioceramic, and nanoparticle-based cements are used. The ideal characteristics for bioactive materials are they should be biocompatible and bioinductive, antibacterial or bacteriostatic property, induces reparative dentin formation, promotes pulp vitality, should be dimensionally stable and should have a good sealing ability. The mechanism of bioactivity, there is ionic exchange, release of calcium, or calcium ions, hydroxyl ions, silicate ions, and there is a raised local pH, which gives the antibacterial effect. Nucleation of hydroxyapatite crystals on the material surface, then the stimulation of odontoblast-like cells differentiate and mineralize barrier formation. This is the mechanism of bioactivity. Moving on to the classification, it was given by Bansod et al. In the year 2023. Based on the cellular response, they are classified as class A is osteoproductive and class B is osteoconductive. Osteoproductive is there is both intra and extracellular responses. An example is Bioglass 45F5. And in class B, osteoconductive, they are able to produce only the extracellular response. Example is hydroxyapatite. And based on dental application, they can be classified as restorative material, demineralizing, desensitizing, and antibacterial. The major bioactive materials in endodontics are MTA, biodentin, root repair materials, bioaggregate, and other newer materials. Now, moving on to mineral trioxide aggregate, MTA. The composition is tricalcium silicate, dicalcium silicate, which gives the strength, then tricalcium aluminate, tetracalcium aluminum ferrite, gypsum and gypsum, which controls the hydration of the hydration reaction. The properties of mineral trioxide aggregate are They have some antibacterial and antifungal properties. They're non-toxic, non-cariogenic, hard tissue inductive and conductive. It's both inductive and conductive, capable to form a peptide-like layer on its surface when come in contact with the physiological fluids or simulated body fluids. They have a long setting time and their compressive strength it increases with the presence of moisture. They have a high pH value. It can rise up to 12.5, which is, and they have a good flexural strength. But when it absorbs excess moisture, the flexural strength decreases. The mechanism of action, when it contacts with the physiological fluid, we saw that there's both inductive and conductive effect. When this mineral trioxide comes in contact with the physiological fluid, there is like an apatite-like layer. There, it releases calcium and phosphorus, then which is needed for the bone metabolism, and then there is bone formation, which is induced. Bone formation is induced, and then the bone forms. Applications is done for vital pulp therapy. It is used as root and filling material, perforation, repair, repairing external and internal resorption. It is also used as apical plug in teeth with open apices and for revascularization as a root canal sealer. Also mineral trioxide aggregate is used. The drawbacks can be this mineral trioxide as a discoloration potential, the presence of there are presence of toxic elements, difficult handling characteristics, there's a long setting time, high material cost, absence of a known solvent for this material, difficulty to remove after curing, has a low compressive strength, which is incompatible with restorative indications. The types of mineral trioxide aggregate are gray MTA and white MTA. This gray MTA, it was the first type which was introduced. It is discoloration potential due to the presence of because of the presence of ferric oxide, there is discoloration in this type of MTA. And then the one which was recently introduced in 2002, which is 2 decades ago, it did not have, it did have a discoloration potential, but due to the reduced amount of ferric uh, ferrous oxide, the potential, that is, the discoloration was less. Moving on to the next bioactive material, biodentin. Biodentin was introduced by Septodont in 2010. It's a calcium silicate-based material supplied in the form of powder and liquid. The composition of powder is tricalcium silicate, dicalcium silicate, calcium carbonate and oxide as a filler. It also has iron oxide and zirconium oxide, which acts as a radiopacifier. In the liquid, we have calcium chloride, which is a hydration accelerator, and water-soluble polymer, which is a water-reducing agent. The properties of biodentin are these are bioactive and biocompatible. It is a dentin substitute. The name itself suggests it is a dentin substitute. The specific feature of this is it has a compressive strength which increases with time until it reaches 300 megapascals, similar to that of the dentin. The initial setting time is 9 to 12 minutes, and the final setting time is 45 minutes, which is comparatively lesser than that of mineral trioxide aggregate. The advantages of biodentin over MTA is that it has an easy handling property, shorter setting time, it has highly purified ingredients, and it can set either in dry or in wet conditions. The uses of biodentin are it can be used in cases of dentinal caries, in cases of pulp exposure, pulpotomy, perforations, internal and external resorptions, apical surgery, and ataxification. Root repair material. It is also a calcium silicate based material supplied in pre-mixed syringe or as a moldable putty form. It's composed of tricalcium silicate, dicalcium silicate, zirconium oxide is a radiopacifier, tantalum pentoxide, and calcium sulfate. The properties are it is a setting time of initially 30 minutes and finally 4 hours in wet conditions, 12 hours in dry conditions. And these root repair material, they are in the size of a nanospheres, okay? They have, since they are nano in size, they have a good penetration into dental tubules, and it also causes micromechanical bonding upon setting. The uses are same as MTA and biodentin. The next is bioaggregate. Bioaggregate, it is aluminium-free calcium silicate cement. The composition is calcium silicate, calcium hydroxide, hydroxyapatite, and tantalum pentoxide. The properties are it is bioinductive and it does not discolor like MTA. And the uses are same. Application root and it has uses of root and filling material, then in case of internal desorption or external desorption. In all such cases, it is also bioaggregate are also used. So to conclude, bioactive materials, these materials have revolutionized endodontics by combining both the sealing ability with the regenerative potential. That is, they are capable of, giving a good seal and also capable of remineralizing the bone. That is the regeneration. Calcium silicate based cements, they remain gold standard for such procedures like apexification and root end filling during apical surgeries and all because of this property. Then again, research continues to optimize longevity, the aesthetic, and true biological regeneration, which is the research is going on in such aspects. And the references are given here. Thank you.